In this video, we will continue with revision exercise 11. You will find this on page 515 in the Namibian AS-Level Mathematics textbook Y equals mx+c to success. In the first part, we did question 1, 2 and 3. Now we will continue with question 4 and 5. Again, what you can do is you can try to do 4, stop the video, and then continue to see if you're correct. And then stop again and do 5 and continue to see if you're correct. Or do both at one stage. Doesn't matter. But let's start with number 4. The equation of the curve, and that's going to be x squared plus y squared minus 4xy plus 3 is equal to 0. Okay. Now, I say show that, so it's differentiation. But if I look at it, I see the x and the y's are mixed. So this is implicit differentiation. Okay, if you cannot recall, first go back and and you will find implicit. I'm just looking where it starts. It starts on page 595. Okay, but let's start. So if I see x, I differentiate to x. If I see y, I differentiate to y. And don't forget, as soon as you differentiate to y, what must you remember? dy over dx. Okay. Let's continue. Then minus, okay. This is the product rule. Do you see there? There are 4x and y. So I rewrite the first one and I differentiate to the second one. Don't forget, dy over dx. Then I continue, plus, I rewrite the second one and I differentiate to the first one. And that is going to be 4x. Okay. And then, let's just control, yes. Then I differentiate to this one, the 3. So plus, and usually we make it x. Let's just move a little bit. And then 3, and then equals 0. Okay, so if I'm going to simplify, this is going to be 2x. This is going to be 2y dy over dx. This, okay, let's just finish this. This is 4x and then 1 and then dy over dx. And this is y and then 4 and I close. And that is 0 and that is 0. Okay, so this is going to be 2x plus 2y dy over dx minus 4x dy over dx, and don't forget, a negative times a positive is negative for y, and that's 0. Okay, now I look at my terms with dy over dx and I take it out as a common factor. So dy over dx, and that's 2y, okay, minus 4x. And then I'm taking the other 2 over, so negative, okay, I can even, let's just take first the y. So 4y minus 2x. And then I divide 2y minus 4x, divide 2y minus 4x. And now, because they said show that, I have to get to that show that. I see that I can take out 2. So if I take out 2, so it's 2y minus x. And if I take out 2 there, it's y minus 2x. And I cancel, and it's going to be 2y minus x and y minus 2x. Okay, and that is what they asked me to show. Okay, now I continue. So that was number A. Now I'm going to continue with number B. Let's just first read what they ask. Find the coordinates of each of the points on the curve where the tangent is parallel to the x-axis. Now, can you remember what I said? If the tangent is parallel to, it's actually the stationary point. Okay, and so I'm going to say, now just tangent parallel to the x-axis, but I can also say if tangent parallel to x-axis, then basically it works that the numerator is equal to 0 or dy, but let's just go to that numerator equals 0. So it's basically this, so 2y minus x equals 0. Now to avoid the fraction, let's take the x over. So x is equal to 2y. Okay, I first leave it like this. Now I'm going to substitute this into my original equation. So substitute, I want to take another color. Substitute, we will now get x also. X equals 2y in the original equation. Okay. And now I'm going to go on. So if I substitute this into my original equation, and what was my original equation? Now, can you remember? I'm first going to write it down into my original equation. I'm first going to write it down here. It was x squared. I just prefer writing it down before I substitute. I can see it, but on my board I cannot see it. If you can see it, you can substitute directly. So 2y squared plus y squared minus 4, 2y plus 3 equals 0. So that's 4y squared plus y minus 8y squared plus 3 equals 0. Okay. So if I simplify this, I'm going to get, and this, let's just quickly see, oh, I forgot that square. I want to say, oh, I think there must be another square. So it's 5 minus 8, so it's negative 3y squared, and that is equal to negative 3, so y squared is equal to 1. So y is equal to plus minus the square root of 1. That means, so therefore, make it red, therefore, y equals 1 or y is equal to negative 1. That then, don't forget, I still have to substitute there. So I say x equals 2y, so it's 2, 1, which is 2, or x equals 2y, 2, negative 1, which is negative 2. And now what is the question asking? Let's just go back. I'll show you. You cannot stop like that. Find the coordinates of each of the points on the curve with the tangent. So therefore, make it red. Therefore, the coordinates are, now I just write, just make sure it was, when it was x was 2, then y was 1. Make sure of your order, and then x is negative 2 and y is negative 1. Okay, and that is basically your two coordinates. And that's how you do number 4, implicit differentiation. Okay, let's do the last one, number 5. Okay. Let's just quickly look. Okay. Okay, there's my space. Let's start with number 5. Now I want you to take note that number 5, I want you to take note of number 5, and on actually just the previous page 514, example 42. But this was a very good example to see that it's actually the same equations, but just asked a little bit different. And this is what can happen in a test or in an examination. So it's always nice to see, oh, but I think I did this already, and what can I recall? So you can actually just look at example 42, just ask a little bit differently. Okay, but I'm going to start with it. Number 5. And now it's parametric equations. Trig equations are, and it's x equals 2t plus ln t, and y equals t plus 4 over t. Okay, so if I want to get this one ready for differentiation, it's t plus 4 and it must come up. Okay, otherwise I cannot. So let's just differentiate. This is dy, not dy. You can see it's dx. Let's get it correct. Dx over dt, and this is going to be just 2 plus 1 over t. That's going to be my first answer. Okay. This one is going to be dy over dt, and this is going to be 1, and if I multiply, negative 4 t to the power negative 2. So it's 1 minus 4 over t squared. Okay. In order to multiply it, I think it will be easier if we first make this one term. Now, how do I make it one term? I basically just multiply t. So it's going to be 2t plus 1 over t. Okay. And if I swap it around, always remember the x1, then it's dt over dx equals t over 2t plus 1. Okay. Now this one, I'm doing the same. Put it over 1. I multiply t squared. So this is going to be, okay, let's just go into white. This is going to be t squared minus 4 over t squared. Okay, so now I can say dy over dx because the t's will cancel out, and then it's going to be t 2t plus 1 multiply this t squared minus 4 over t2. Okay, now I wrote it like this that you can see, because now it's just going to be t and t squared minus 4 over t squared 2t plus 1. But can you see that one of the t's can cancel out? So it's going to be t squared minus 4 over t 2t plus 1. Okay, and that's what they said. Show that it's t squared minus 4, t, 2t plus 1. Remember what I said. This was number A. If you did not come to this, try still to do number B. Use this answer they gave you in A and see if you can continue in B. Okay, but this was number A. Let's maybe mark it very nice. This was A. Now I go on with number B. Okay, so first let's read number B. I think I'm going to, yes, not it's so long, but I'm going to do B here. The curve has one stationary point. Find the y coordinate of this point and determine whether this point is a maximum. So in this, it's different from example 42. I didn't ask the coordinate. Now I'm asking the coordinate. So the first, at the stationary point, and remember, I'll show you now, stationary point, I can say that dy over dx x equals 0. Okay, so I'm basically going to say that t squared minus 4 over t 2t plus 1 is equal to 0. And remember, it's actually over 1. So in parametric equations, basically, I'm not getting x and y values. I'm first going to get the value of t. And then I take the value of t and I substitute it into, if I want to get the coordinate, into the x, then I will get the x value of the coordinate. And if I want to get y, I substitute the value of t into the y to get that coordinate. Okay. So basically, this is just going to be t squared minus 4 is equal to 0. So I have t squared is equal to 2. So t, so not 2. You see, stupid mistake I make. I'm already, I don't know where, but I want to get it clean. 4, coming over, 4. And then it's plus minus the square root of 4, and that's why I was thinking of 2 already. Plus minus of 2. But I want there, t takes all positive values. So t is bigger than 0, so and I always like to write that. Therefore, t is positive 2, or just 2. Okay, not the negative option. Okay. Now I go on. Now they say I must still find, and I'm going to do it here. Usually I don't like it if you write next to each other, but in this case, okay, just to get the y. So I go to my original equation because they are asking me, what did they ask me? Find the y coordinate. They just want the y. So I go to y, and remember y is t plus 4 over t. So it's that 2 plus 4 over 2, and that's 2 plus 2, and that's 4. Okay, so basically the y coordinate of this stationary point, therefore y coordinate of 3 point is 4. Okay, so that's the first part. Now I do determine whether this point is a maximum or a minimum point. Okay, and now this is also that you only do it when it's this parametric equations. It's a little bit different from normal stationary points. So can I just go on and I can say nature of stationary point. Okay, and now this is very important that you remember it with parametric equations. We are going to find d squared y over dx squared, but it's different. You are going to differentiate the dy over dx, and then you multiply it with dt over dx. Okay, and then you do the substitution. But let's first do that. So basically, I'm just going to move it up. So if I'm going to get, and this is quite a lot of writing, so I'm going to get d2y over dx squared, and that is going to be, okay, d over dt, and then it's t squared minus 4 over, and I'm going to write it like this, but I'll show you what I do also. So 2t plus 1, okay, and multiply, and that dt over dx is t over 2t plus 1. Okay. Now, if I'm going to differentiate this is the quotient rule. Now, I prefer that if you come to this one, you multiply it in, but there's a reason why I leave it also like this, and I'll show you now why. Okay, so remember the quotient rule. I rewrite the denominator, and I think for now, for the top, I'm going to multiply it in. So it's going to be 2t squared plus t. So I rewrite the denominator. I differentiate the numerator, the quotient rule. Okay. Subtract. I rewrite the numerator and I differentiate. I say dx, please. Did you pick it up? I hope so. It's dt, because I differentiate to t. So dt, and okay, now I must just think again. I rewrite and I differentiate this one. 2t squared plus 2. Okay, let's just see. It's not plus 2, it's plus t. It was also a mistake. It's that multiplying in. So I think not to confuse you, just write it here. It's 2t squared plus t. That's the denominator. Okay. So 2t squared plus t. Okay. And then it's over, and I take the denominator and I square it. Okay. And I multiply with the t, leave it for last, 2t plus 1. Okay, now let's just do all this writing. So in the first case, I'm just having the bracket 2t squared plus t. And if I differentiate that one, it's 2t minus. This is going to be t squared minus 4. And now this is going to be 4t plus 1. And I'm closing, and if I square this, so it's t squared, square the bracket, 2t plus 1. Okay. And don't forget to square. I'm still more multiply it with t, 2t plus 1. It's just a lot of multiplying. Okay. I think sometimes, because you're just going to substitute 2, you can just substitute it in here and just get an answer, because you actually just want to see if it's bigger than 0 or smaller than 0. Okay, but for explanation's sake, I'm going to continue on. Okay, so if I multiply, I'm going to get 4t3 plus 2t squared. Okay, that is going to be. If I multiply out this, so minus, and I could have already, but let's just get, this is 4t to the power of 3 plus t squared minus 16t minus 4. Okay. This is going to be over t squared 2t plus 1 squared. Multiply this t over 2t plus 1. Okay. So if I simplify this, and I'm doing it a little bit long, far too long, but it doesn't matter, just for the video's sake. t3 minus t squared plus 16t plus 4. Over t squared 2t plus 1 squared. Okay, let's simplify. Don't forget, I still have to, I'm just running it around. 2t plus 1. I will now bring it in. Okay, so first you see that this will cancel. Oh, thank you. This is 2t, so this is going to be just t, okay, plus 16t. Let's just see, plus 16t plus 4. Plus 4. Okay. And okay, if I multiply this one now in, put that t in front, and do you see that this bracket is the same as this? So I can make it t squared, and I can make just that bracket to the power of 3. Okay, and if I really want to still simplify it, I can then go and say this is t squared plus 16t squared. Okay, let's just see. I think there was a mistake. This was supposed to be a square. Do you see? Because it was that one. Oh, so many. So this is going to be 3. This is going to be 16t squared. This is 4t. Okay. Over t squared 2t plus 1 to the power of 3. Okay. So when, and continue, so when t is 2, then, okay, it's going to be 2 to the power of 3 plus 16, oh, let's see, yeah, 16, 2 squared plus 4, 2 over 2 squared, 2 plus 1, and it's a 3. Okay. And then if I simplify this, okay, this is now just a lot of simple calculations. So this is going to be 8. This is going to be 4 times 16, and that's going to be 64 plus 8 over, and now I'm just going to get, this is 4, and this is 5 to the power of, it's 125. And if I simplify this further, I'm going to get that 80 over 500. And now I end up by saying, okay, therefore, d square, okay, let's just write it correct, d squared y over dx squared is bigger than 0. So the stationary point is a minimum point. Remember, if it's smaller than 0, it's a maximum point, and if it's bigger than 0, then it's a minimum point. And that's how we do it.